All right, team, let's talk metadata. Sounds boring, right? I know. But trust me, it's the secret sauce to a smoothly running data platform, and therefore your career or business. Think of it as the brain behind your data operation. Without it, things get messy fast. So, what is it? Essentially, we've got two main flavors of metadata: business metadata and data platform internal metadata, which some folks like to call pipeline metadata because, we need more jargon in our lives. Business metadata is the stuff your business users care about. It's the what and the why of your data. Pipeline metadata, on the other hand, is the how. It's the nitty gritty details about the data pipelines themselves, the behind the scenes magic, or sometimes mayhem, that makes your data flow. Now, why should you care about pipeline metadata? Because it's absolutely fundamental to keeping your data platform from turning into a complete dumpster fire. We're talking automation, monitoring, configuration management, all the good stuff that keeps things running smoothly. Without it, even a platform with just a handful of data sources and pipelines will quickly become a nightmare to manage. Imagine juggling chainsaws while riding a unicycle. That's your data platform without proper metadata. So, what does this metadata layer actually do? Think of it as a multi talented Swiss Army knife. It has three main jobs. Number one, central storage. It's the central hub for all your pipeline configurations. No more hunting through endless folders. It's all right there. Number two, execution tracker. It keeps tabs on how your pipelines are doing. Did they succeed? Did they fail spectacularly? How long did they take? It's got all the juicy details. Number three, schema repository. It's like a library for your data schemas, but way cooler, I promise. Within this metadata layer, there are really two different types of information being stored. The first is configuration metadata, which is a fancy way of saying details about how your pipelines are set up. And then we have activity metadata, which is basically a log of everything that's happened during your pipeline executions. Now, let's break this down even further. We can group these metadata items into four main domains. Number one, pipeline metadata, configuration. This is the who's who and what's what of your data platform. It lists all your data sources, destinations, and the pipelines that connect them. Number two, pipeline activities, activity. This is the gossip column of your platform. It tells you which pipelines aced it, which ones face planted, how long they took, and even how much data they moved. Number three, data quality checks, configuration. Because garbage in, garbage out, right? This part keeps track of the quality checks you've put in place to make sure your data is squeaky clean. Number four, schema registry, configuration. As mentioned, this is going to be important, so let's save the deep dive for a little later. Here's the best part. Instead of messing with complicated code every time something needs to change, your data engineers can simply tweak the configuration in the metadata layer. It's like using a remote control instead of rewiring your TV every time you need to change the channel. This makes scaling your platform a breeze. And if a pipeline goes belly up, your engineers can quickly check the metadata layer to figure out what went wrong. Data users, especially your power users, will also love it. They will know exactly where the data is coming from and going. It's like having a GPS for your data. This metadata layer, it should be the primary way your data engineers and advanced users interact with the platform. Think of it as a VIP entrance for data wranglers. Now, you might be wondering how to actually build this magical metadata layer. There are a few different ways to go about it, from storing configuration files in cloud storage, the budget-friendly option, to using a dedicated database with a fancy REST API for the high rollers. My advice? Start simple and evolve as your needs grow. Don't buy a Ferrari when a reliable used car will do the trick, at least for now. Truth be told, there aren't any rock-solid industry standards for pipeline metadata models yet. And most of the software and cloud services out there don't fully cover everything we talked about here. But hey, that's why you're taking this course, right? To be ahead of the curve. Amazon, Google, and Azure do have some metadata services. And there are even a few open source options like Apache Atlas, Data Hub, and Marquez that might give you a head start. So there you have it, metadata. It might not be glamorous, but it's the key to a well-oiled data machine. All right, let's talk about something that might sound a little dry as well, schema management. But trust me, it's a way bigger deal than you think, especially if you want a data platform that doesn't make you want to pull your hair out. Think of traditional data warehouses like that super organized friend that needs to know exactly where everything goes before they even start packing. They're all about relational technology. This means you gotta define the structure of your data up front. Column names, data types, the whole shebang, before you load anything in. It's like pre-planning your entire data life. Now, imagine your data source is like a teenager going through a growth spurt, constantly changing. Maybe it adds a new column, like a new interest, drops an old one, like that embarrassing phase they'd rather forget, renames something, or even changes the type of data it's holding. These are what we call schema changes. If you're not prepared, these changes can wreak havoc on your carefully crafted data setup. Your ETL, extract, transform, load jobs, basically the process of getting data into your warehouse, can break. And suddenly, nobody's getting the data they need. It's a recipe for unhappy data consumers. And trust me, you don't want that. Dealing with schema changes is kind of manageable when you're the boss of the application producing the data. You can plan for it. But what happens when you start pulling in data from outside your little bubble? Say, from third-party SaaS companies? That's like inviting a bunch of unpredictable guests to your meticulously planned party. Chaos, right? Luckily, we can wrangle this chaos within our data platform. Here's the secret sauce. Number one, resilient ATLs. We can detect and ideally adapt the schema changes before they blow up our pipelines. Think of it as having a super smart bouncer at the door of your data party, keeping things under control. Number two, a living, breathing schema catalog. This is like your data party's guest list, but way more useful. It keeps track of all your schemas, making it easy to find what you need and even do some data discovery. Self-service for the win. Number three, schema history. Ever wish you could go back in time and see how your data has evolved? Well, with a schema history, you can. It's like a time machine for your data, helping you understand archived data and debug your pipelines without the headache. So, how do we make this magic happen? In a well-architected cloud data platform, we have something called Schema Registry. Think of it as the master record of all schemas, past and present. It's tucked away in the metadata layer, kind of like the brain of your data operation. Our data transformation pipelines, or even curious humans, can peek into this registry to see the latest schema for any data source. They can even explore past versions, like flipping through old photo albums to see how a data source has matured over time. Now, let's get a bit technical. In our cloud data platform, we can add a schema management module to our pipelines. This module is like a detective. It checks if a schema or a data source already exists in our registry. If it's brand new, the module will infer the schema from the incoming data and register it as version 1. Pretty smart, right? If the schema is already in the registry, the module fetches the current version, infers the schema from the new data, compares the two, and then creates a new backward compatible version that includes both old and new stuff. It then publishes this updated schema back into the registry for everyone to use. Now, schema inference works great when you're dealing with batches of data, But for real-time data, it's like trying to catch a greased piglet. Not gonna happen. We could try to figure out the schema for every single message, but that's a ton of work, and we'd end up with a million different schema versions. Not ideal. So here's the plan. For batch data, we can let our smarty pants schema inference do its thing. For real-time data, we'll rely on manual schema management. This means our development teams are responsible for publishing schemas and updating them when things change. It's a bit more work, but it keeps things manageable. Sometimes, even with all this automation, we hit a snag. There are certain schema changes that we just can't handle automatically. That's when we need an alert system, a little red flag that tells us, hey, this change might cause problems downstream. Our metadata layer also have pipeline configurations. It's like a map that shows which data sources feed into which pipelines. So if we know a data source has a schema change that's going to make waves, we can easily see all the downstream pipelines and reports that will be affected. No more nasty surprises. Finally, about the schema registry itself. There are existing solutions like AWS Glue Data Catalog, Azure Data Catalog, and Google Cloud Data Catalog, but they might be a bit limited for our needs. Other options, depending on how fancy you want to get, include, number one, a simple config file, versioned in a code repository. Easy peasy. Number two, a key value or relational database to store your configs and other metadata, more robust. Number three, a REST API. Put this on top of your database and you've got a uniform way for all your tools to access the metadata. Now you're really cooking. So there you have it. Schema management might not be the most glamorous topic, but it's essential for building a robust and scalable data platform. By mastering these concepts, you'll be well on your way to taming your data and unlocking its true potential.